This next step that we're going to take with completing the square and solving quadratic equations by completing the square will be tackling equations where the coefficient of the x squared term, so for example right there I just circled the 5, is no longer just a 1. That's what we restricted ourselves to previously. So yeah, as we jump into this guy right here, we'll specifically use that technique of completing the square to help us to be able to solve this equation. So like we learned with completing the square in the first part of things here, it's really nice to be able to get the x squared term and the x term alone on one side of the equation, and then if you can get the constant to the other side, it's a nice good starting point. So if you then subtract the 50 right there, that'll get the constant over the other side. So you'll end up getting 0 minus 50 on the other side, which of course is going to be equal to negative 50. So now with this new equation right here, we'll eventually want to complete this square, but it's easiest to complete the square if you have just a 1x squared. So one thing that we can do to both sides of this equation then is then we can divide or multiply, whatever you need to do, so that you can change that number in front of x squared to become a 1. So in this case, we'll want to divide by a 5. So if I divide everything on that side by 5, you're going to end up with then 1x squared, and then 40 divided by 5 is 8. So x squared plus 8x on that left side. And then if you do the same thing to the other side for the equation, of course, to keep that balance, then negative 50 divided by 5 there is going to give you negative 10. All right, so once we arrive to right here, then this is just completing the square as per normal like we did back in the first part. And so since that b coefficient right there is an 8, if you take half of 8, you're going to get 4, and then you square the 4 and you get 16. So it turns out that we're going to have to add 16 to complete the square and make that there be a perfect square trinomial, because we'll be able to factor it as x plus 4 times x plus 4, which in other words is x plus 4 squared. So of course you have to do the same thing to the other side of the equation to keep the equation balanced, and add 16. And then if you add those couple things together, negative 10 plus 16 is going to give you 6. So we'll end up with then that x plus 4 squared equals 6. And then, yeah, you can just use the square property and then get x alone, and you're pretty much golden from there, right? So we can take the square root of both sides. That means then that you are going to get x plus 4 only on that left side. And then you'll get both positive and negative the square root of 6. You can't simplify square root of 6 any further. It's already in the simplest radical form. And so then finally, if you cancel out the plus sign of the 4 right there, you'll just subtract 4 to both sides, which means that you get a negative 4 in front right there, plus or minus the square root of 6. And then that right there is going to give you the solutions for x. And then just jumping over to this fella over here. So we're going to try to use completing the square to do so. So just similar to the last example, it's really nice if you get the x squared and x term on one side. So I'm going to leave like this x squared term where it is on that right hand side of equals, but you can see that there's this 8x right here. So I'm going to go ahead and subtract 8x from both sides, and then that means that when I subtract 8x on that side, we'll end up getting the minus 8x right there. And then it's nice to get the constants all on one side. So if I subtract the 12 there, and then subtract the 12 there, then on the other side here, we're going to get negative 12 minus 12, which is negative 24. Okay, so we've got this blue equation, and then from here, we will want to try to complete the square, but we're going to want to make for sure, first of all, that we have a 1 there in front of the x squared. So let's go ahead and then divide everything on that side by 2, and everything on that side by 2, because then that accomplishes our goal of getting 1x squared, and then you're going to get negative 4x, because that's negative 8 divided by 2. And the other side, you're going to get negative 12. And then we'll just complete the square. So since your b value right there is negative 4, half of that is 2, and then 2 squared is 4. So yeah, you can add 4 right there, and then you can add 4 to the other side. So that's going to give us then that negative 8 is equal to, if I factor this, is x minus 2 times x minus 2. So the quantity of x minus 2 squared. And then we can just solve by using the square root property. So we'll square root that side and square root that side. So you'll notice that right there, we're taking the square root of a negative. So we know that's going to be imaginary. And then you can also reduce the square root of 8 because it's the same thing as the square root of 4 times the square root of 2. And so since the square root of 4 is 2, it's the same thing then as 2I root 2. And we'll want to make sure that we have both positive and negative values there. And then that's going to be equal to just x minus 2. And so finally, if you add 2 to that side and then add 2 to the other side, you're going to get 2 plus or minus 2I root 2 as your solutions for the values of x for that equation there. All right, so as we saw there, just kind of really making sure that we get a 1 in front of the x squared before we complete the square. And so now as we move into the next few examples right here, we're going to result in some b values that are odd, and so we're going to kind of run into some fractions and decimals and that sort of stuff. So you'll see what I mean as we start doing this one here. So we'll again use the completing the square technique to try to solve this equation, and you'll notice that actually we do have a 1x squared, so that's beautiful, right? So what I'm actually going to do to first start this off here first is get the x squared and x term on that side, and then let's get this constant of 6 to the other side, so let's subtract 6 to both sides. That means then we get negative 6 there equals x squared plus 5x. So now, since the b value, so this guy right here, the 5 is odd, when you divide it, you're going to get a decimal, right? So it is 2.5 if you take half of 5, but I'm going to treat that as a fraction. So rather, if I get half of it, it's 5 halves, right? And then I'm going to want to square what 5 halves is, and that's going to be what I need to add as a c value to complete the square right here. So if I square 5 halves, it's the same thing as 5 halves times 5 halves. So you'll get 5 times 5 on top, which is 25, and then 2 times 2 on bottom, which is 4. So we're going to end up getting the 25 fourths as the value to complete the square. So to keep the equation balanced, we're going to add 25 fourths to the other side. And so what I'm going to need to do right there is I'm going to need to add those couple of numbers, the negative 6 with the 25 fourths. So to do so, it'd be great to get a common denominator. So we could use a common denominator of 4, and negative 6 is the same thing as negative 24 fourths. So then I can add those couple of things together and get positive 1 fourth when I add those fractions together. On the other side, we'll be able to factor that. So since we used 5 halves as half of 5, then that's actually the value that would be inside the parentheses right there with the x, so x plus 5 halves squared. So that's the correct factorization. So now we've gotten to this point right here, and then we can use the square root property to solve. So we can square root that, and you'll notice then that's kind of breaking one of those rules of simplest radical form, because we don't want to keep a fraction inside of a radical, right? So we know that that's the same thing as the square root at the top times the square root at the bottom, which then actually we know the square root of 1 and we know the square root of 4, because the square root of 1 is 1 and the square root of 4 is 2. So it turns out to be 1/2, and then we'll want to make sure that we have both plus and minus. And then if I square it the other side, you end up getting just x plus 5 halves. And then, yeah, great. So then if you subtract the 5 halves to cancel that out, and you subtract the 5 halves to the other side, we're going to end up getting then that negative 5 halves plus or minus 1/2 is going to equal x. So you can actually figure out what those two numbers are going to be, because if you plussed it, negative 5 plus 1 is going to give you negative 4 halves. And then if you minused, negative 5 minus 1 is going to give you negative 6 halves. So yeah, if you reduce each of those fractions, negative 4 halves is going to give you negative 2. And negative 6 halves is going to give you negative 3. So therefore, actually, the whole number is negative 2, or I guess integers, negative 2 and negative 3 are going to be the solutions to that equation. Okay? So I want to just kind of go back to the original problem that we had, because I want you to realize that we don't necessarily have to always solve a quadratic equation by completing the square. Of course, that's what we did because we were asked to do here. But just like personally, if I were seeing this equation, 0 equals x squared plus 5x plus 6, and just asked to solve it, but I don't have to use like a particular method, I would actually just factor it, because it's kind of easy enough to be able to factor and then use the zero product property, because if you factor the right-hand side, you can do x plus 2 times x plus 3 to factor the expression x squared plus 5x plus 6. And then if you use the zero product property, then that allows us to conclude then that x equals negative 2 or x equals negative 3. So you get it pretty quickly that way, right? But completing the square, of course, works as well. All right, so then with this fella right here, you can see that actually we have the x squared term and the x term alone on one side, and then you have a constant on the other side, which is great for completing the square, but you'll also notice that we've got the 3 in front of the x squared. So we're going to want to make that become a 1. So let's divide everything on this side here by 3 then, and divide that there by 3. So if you divide that out, you're going to end up getting negative 79, and then it's going to be equal to 1x squared, and then negative 57 divided by 3 is negative 19x. All right, so from there then, we can then try to complete the square. So if our b value is a negative 19, then I want to first of all find what half of that is, which is going to be negative 19 halves, keeping that just as a fraction. And then if I square that, negative 19 times negative 19 ends up giving you 361. And then on the bottom, 2 times 2 gives you 4. So we're going to have to add 361 fourths to complete the square. So what will happen then is that trinomial right there will factor nicely as x minus 19/2 squared. And then we'll have to make sure that we also add 361/4 to the other side to keep this equation balanced. And so then with that left-hand side, we're going to need to get a common denominator of 4 to add those couple numbers together. So it ends up being negative 316/4 is the same thing as negative 79 when you get that common denominator. And then you have to add those couple fractions together. And that's going to give you 45/4 if you add that all together. So if I just kind of slide this guy down here, we can say that there's equality holding right there. And then we can just kind of finish this off by using the square root property and simplifying as needed, right? So if we square root both sides, you'll notice that the 45 is not a perfect square, but the 4 is a perfect square. So we'll definitely get a 2 on the bottom because the square root of 4 is that. With a 45, we can kind of simplify that a little bit because we know that the square root of 45 is the same thing as the square root of 9 times the square root of 5. So we'll be able to write that as 3 square root of 5 then. So we get 3 square root of 5 over 2, both positive and negative, and that's going to be equal to x minus 19/2. And so then finally, if you get the x alone, then the x will be equal to positive 19/2 plus or minus 3 root 5 over 2. All right, excellent. So yeah, that just gets kind of into the territory of some fraction sort of stuff, and that really happened because our b value in both of those cases were odd. So we had that 5 there and the negative 19, and so when you half them, you end up getting, fractions and that sort of thing. Okay, so then I want to look at some ones where actually the b value itself is a fraction when you're trying to complete the square, and that's going to happen in these couple examples right here. So we'll start with this fella right here. If we're going to complete this square, again, it's really nice to have the x squared term and the x term on one side, and then let's add the 3. So we get the constant to the other side. So then that's going to be equal to 0 plus 3, which is 3. And then as we know, we want to make sure we have a 1 in front of the x squared. So then we can divide both sides of the equation by 8, so that then you get a 1x squared. And then right there, you're going to end up with negative 2/8 x, but negative 2/8 reduces down to negative 1/4, so minus 1/4 x, and that's going to be equal to 3/8, okay? All right, so now our b value is a negative 1/4, and so if you find half of negative 1/4, half of negative 1/4 is negative 1/8, and then if we take the negative 1/8 and we square that, then the negative 1 times negative 1 on top is going to give you 1, and then the 8 times 8 on bottom is going to give you 64. So by adding 1/64, then that will complete the square. And so it will allow us to then take that trinomial and factor it as x minus 1/8 times x minus 1/8, so x minus 1/8 squared. And then we'll want to make sure that the other side of the equation also gets 1/64 added to it so that we balance that equation nicely. So we can get a common denominator by using a 64. So that means that we're just going to need to take this 3/8 and multiply it by 8 over 8. So we get that denominator of 64. So you'll end up getting then 24/64 to add with 1/64. That'll give you then 25/64 when you add that all together. All right, so now with this black equation right here, then we can use the square root property to isolate just the x minus the 1/8. And then if you square root that, it turns out that both the numerator and denominator are perfect squares, so we got 25 and 64. So you end up with plus or minus 5/8, since those are the square roots of those couple numbers. And then, yeah, then you can just add the 1/8 to get the x alone. So positive 1/8 plus or minus 5/8 will give you your solutions, and you can actually get very nice answers from that. So if you plus, then 1/8 plus 5/8 gives you 6/8. And then if you were to minus, 1/8 minus 5/8 is going to give you negative 4/8. So with those couple numbers that we just found, you can actually reduce both of them, because 6/8 is actually 3/4, and negative 4/8 is negative 1/2. So x is going to be equal to 3/4 or negative 1/2 as the solutions to that equation. And then another one here is this fella right here. So first of all, I'm going to get the 4x squared and the 4x and just kind of leave them as they are. And then let's get this 19 canceled out. And then if I subtract 19 from negative 57, you're going to end up with the number negative 76. So then we want to make sure that we get a 1x squared, so we're going to have to divide that side by 4 and that side by 4. So you're going to get then 1x squared and then also 1x. And then on that side, you're going to end up with negative 19 when you divide negative 76 by 4. So since your b value here is a 1, you're going to want to take half of that, which is half, and then square it, and whatever that is will be the c value that you're going to add. So 1/2 squared would be 1 times 1, which is 1, and 2 times 2, which is 4. So it does turn out that we're going to have to add 1/4 to complete the square. So then taking this right here and factoring that, that's going to be x plus 1/2 squared. And then the other side of the equation, we're going to have to add 1/4 to that as well. So we'll need to get a common denominator with this. So it turns out that negative 76/4 is the same thing as negative 19. And then 1/4. And then if we add that together, negative 76 and 1 will add to make negative 75. So it equals negative 75/4. Alright, so from that then we can use the square root property to solve from here. So if you square root the left-hand side, you'll end up with x plus 1/2. And then the other side, you notice that we're square rooting a negative, so it's definitely going to be imaginary. So plus or minus something involving I. 75 itself is not a perfect square, but we know that 75 is the square root of 25 times the square root of 3. So you'll be able to write that as 5i root 3 then, when you simplify that part. And then 4, it's a perfect square, so it's just going to be 2 there in the denominator. So finally, if you subtract that 1/2 to get the x alone, then x will be equal to negative 1/2 plus or minus 5i root 3 over 2. And then this last example here, in terms of completing the square, actually has a decimal itself for its b value. So I'm going to just take the x squared and the 4.8x and leave them as they are. Let's get the 1 to the other side. So let's add 1 to both sides, and that means we're going to get 1 on that right-hand side. So to complete the square here, we just need to take half of the 4.8, and we can do that right away because there's just a 1 in front of the x squared. So yeah, half of 4.8 is going to give you 2.4, and then if you square that, that is going to give you 5.76, what we need to add to complete the square. So if we were to then factor that left-hand side, it factors as x plus 2.4 times x plus 2.4. And then similarly, if we go to the right-hand side here and we add 6.76, or add 5.76, sorry, we will get 6.76 once we add 1 to 5.76. There we go. Okay, so now we can use the square root property. So if we square root that side, you'll get just x plus 2.4. And then it turns out that if you put that into a calculator, it comes out to be just the nice 2.6 decimal number right there. You'll get both plus and minus, since we square rooted that number. And then finally, you can get the x alone if you subtract 2.4. So x is going to be negative 2.4 plus or minus 2.6. So what you would get if you plussed negative 2.4 with 2.6 is you would get 0.2. And then what you would get if you minused negative 2.4 and or do negative 2.4 minus 2.6 is you get negative 5. So those values right there of positive 0.2 and negative 5 would be the solutions for that equation.